Hello and welcome to SigmaXL video tutorials. This is part 1 of the Introduction to Control Chart Templates video series. In this video, we'll be looking at Rare Events templates found in SigmaXL. Rare Events T, Rare Events G, and Rare Events Prob G. We'll begin with the Rare Events T chart. The Rare Events T chart, or time between chart, is an alternative to a standard attribute chart when the adverse event of interest is relatively rare and a measurement of time between each occurrence can be obtained. If the rate of occurrence follows a Poisson distribution, the usual assumption for a C or a U chart, then the times between occurrences will have an exponential distribution. The exponential distribution can be transformed to a symmetric Weibull distribution by raising the time measure to the 1 over 3.6 power. A Shewhart individual's chart is calculated on the transformed data, and then an inverse transformation is applied to the control limits in order to get back to the original time between units. This is an approximate model to the exponential and will result in asymmetric control limits. Note that an out-of-control signal above the UCL is desirable, indicating a significant increase in time between adverse rare events. The Provost and Murray book is popular in healthcare, so SigmaXL uses the control limit calculations as given in the book, where T equals time between incidents and Z equals transformed time. For additional information, please see the SigmaXL workbook. For this example, I'll be using the days between surgical site infection sample data in SigmaXL. Days between surgical site infections are an important healthcare metric. Since they are rare events, days between or time between events are tracked rather than events per day. The event date/times from January 1st, 2019 to June 13th, 2019 are before improvement, and the days between will be used to calculate the control limits. Date/times June 14th, 2019 to February 26, 2020 are after improvement, and the days between will be added to the control chart. The goal is to decrease the occurrence of surgical site infections, which increases the days in between, with an out-of-control signal above the upper control limit being desirable and confirmation of the improvement effort. Click SigmaXL, Control Charts, Control Chart Templates, Rare Events, Rare Events T. We're going to copy and paste our data into the template, so reopen the days between surgical site infections, copy the before improvement date/times in cells A1 through A22. Paste the values to the template at A1. Note that the days between are automatically calculated using the Excel formula equals A3 minus A2 equals A4 minus A3, etc. Cell B2 is not used. Click the Rare Events T control chart button to create the Rare Events T control chart. This confirms that the process is in control. As discussed earlier, the control limits are asymmetrical. Although the process is in control, as a critical healthcare metric, efforts were made to improve the process, and this data will now be added to the chart. Switch back to the days between surgical site infections data. Select and copy the after improvement date times in cells A23 through A32, as I'm demonstrating here. Switch to the Rare Events T control chart template and paste the values to cell A23 on. Click the Add Data button. This will add the new days between data to the Rare Events T control chart without recalculating the control limits. This confirms that the process is now out of control, so the improvement efforts to decrease the occurrence of surgical site infections and increase the days between have been successful. Note that the control limits should be recalculated with just the after improvement data when a minimum of 20 data points are available. Now I'll demonstrate Rare Events G. The G chart, or geometric chart, is an alternative to a standard attribute chart when the adverse event of interest is rare and discrete opportunities between events are counted. For example, number of units or days between. The calculation of control limits is an approximation based on the geometric distribution. As with the T chart, an out-of-control signal above the upper control limit is desirable, indicating a significant increase in units, opportunities, or days between adverse rare events. As with the Rare Events T control chart, SigmaXL uses the control limit calculations given in the Provost and Murray book. For more information, please see the SigmaXL workbook. For this example, I'll be using the doses dispensed between adverse drug events sample dataset in SigmaXL. Adverse drug events are rare, so doses dispensed between ADEs is used as a healthcare metric. The data is discrete and distributed geometrically, and the G-chart is appropriate to use here. The event dates July 2, 2019 to September 24, 2019 are before improvement, and the doses between ADEs will be used to calculate the control limits. Dates September 28, 2019 to January 17, 2020 are after improvement, and the doses between ADEs will be added to the control chart. The goal is to decrease the occurrence of ADEs, which will increase the doses between, with an out-of-control signal above the UCL being desirable and confirmation of the improvement effort. To open the template, click SigmaXL, Control Charts, Control Chart Templates, Rare Events, Rare Events G. Switch to the Doses Dispensed Between Adverse Drug Events workbook and copy the before improvement data in cells A1 through B21. Paste the values to the template at A1. This will overwrite the formulas in column B. Click the Rare Events G Control Chart button to create the Rare Events G Control Chart. This confirms that the process is in control. Although the process is in control, as a critical healthcare metric, efforts were made to improve the process, and this data will now be added to the chart. Switch back to Doses Dispensed Between Adverse Drug Events. Select and copy the after improvement date times in cells A22 through B31. Switch to the Rare Events G Control Chart template and paste values to cell A22. This will overwrite the formulas in column B. Adjust the template column widths as necessary. Click the Add Data button to add the new doses between events data to the Rare Events G Control Chart. This confirms that the process is now out of control, so the improvement efforts to decrease the occurrence of ADEs and increase the doses between have been successful. Now I'll demonstrate Rare Events Prob G. The Rare Events probability-based G-chart is similar to the G-chart but uses probability-based control limits. This is recommended in order to properly control the type 1 false alarm error rate. The calculation of control limits is based on the geometric distribution. Event probability and alpha are used to compute the non-symmetrical limits. Similar to the G-chart, an out-of-control signal above the UCL is desirable, indicating a significant increase in units, opportunities, or days between adverse rare events. For more information on calculating the control limits, see the SigmaXL workbook. For this example, we'll use the same sample data demonstrated for Rare Events G, doses dispensed between adverse drug events. Click SigmaXL, Control Charts, Control Chart Templates, Rare Events Prob G. Switch back to the doses dispensed between adverse drug events example data. Copy the before improvement data in cells A1 through B21 and paste the values to the template at A1. We'll use the default alpha UCL equals 0.00135. This corresponds to the one-sided probability for UCL in a classical Shewhart control chart with 3 sigma limits. Click the Rare Events Prob G chart button to create the Rare Events probability-based G control chart. This confirms that the process is in control. Note that the probability-based UCL is much larger than the one calculated using the regular G chart. If the UCL is considered to be too large for practical use, adjust the alpha UCL to a larger value, for example, 0.01 instead of 0.00135, and recreate the control chart. Note that this will increase the type 1 false alarm rate. As with the G chart, we will add the data from after the improvement efforts were made to this chart. Switch back to the doses dispensed between adverse drug events example data. Select and copy the after improvement date times in cells A22 to B31. Switch to the Rare Events Prob G chart template and paste values to cell A22. Adjust the template column widths as necessary. Click the Add Data button to add the new doses between events data to the control chart. This confirms that the process is now out of control, so the improvement efforts to decrease the occurrence of ADEs and increase the doses between have been successful. This concludes part 1 of the control chart templates tutorial video, Rare Events. For more videos, visit www.sigmaxl.com or join us on YouTube. Thank you for watching.